Welcome you all. Today we are going to discuss about simplex method. Under simplex method we are going to discuss on graphical method. We will take a problem and we will see how we are going to solve this simplex using your graphical method. So I have taken a problem. The problem is maximize z equal to 12x plus 12x1 plus 16x2. Okay, and it is subject to 10x1 plus 20x2 less than or equal to 120, and they have given another equation 8x1 plus 8x2 less than or equal to 80, and both x1 and x2 are found to be greater than or equal to 0. Now I am going to solve these two equations and I am going to find out what can be the feasible points for x1 and x2. If x1 and x2, what can be the values of x1 and x2 so that z will be in maximum value. So I have taken the first equation, that is 10x1 plus 20x1 equal to 120. Now what I am going to do was, first I am going to substitute any one of the unknown variable as 0 and I am going to find out the other point, and then again I am going to repeat the process. Okay, here two unknown variables are there, one is x1 and x2. So first I am going to substitute x1 as 0. So when I am substituting x1 as 0, 10 into 0 plus 20x2 equal to 120. While solving that, I am getting x2 equal to 6. Then I am doing the same process. The next unknown variable is x2. Okay. So when I am substituting x1 as 0, I am getting x2 as 6. So in a graph, this is my x-axis and this is my y-axis. I have plotted points. So when x1 is, this is x1 and this is y1. So when x1 is 0, I get x2 as 6. Okay. So here x2 as 6 and x1 is 0. I have pointed out. Now I taken x2 as 0. So now 10x1 plus 20 into 0 equal to 120. So while solving that, I am getting x1 as 12. So I have plotted this, I have connected. So this is a region I get for the first equation. Okay, so now I am moving on to second equation. Again I am going to repeat the same process. I am substituting x1 as 0 and I am finding out my x2. So it is found to be 0, 10. So I have pointed that. Okay, then I am substituting x2 equal to 0. I am getting again 10 because both x1 and x2 coefficient are found to be 8. It's found to be equal. So I am plotting that. I am drawn a line. Okay. So now I have got two lines. Okay. So see here. So this is solving the second equation. This is solving the second equation and this is solving the first equation. So in this, okay. So in this I am supposed to, this is the feasible region. So when I am considering these two lines, this is found to be an feasible region. So I have shaded using lines. Okay. So now I am going to substitute the values. So this is the feasible region. Okay. I am substituting the values. X1 is 0 and x2 as 0 in my maximizing function. I am getting 0. And then I am substituting 10 comma 0. Okay. I am getting 12. Then I am substituting, what is that? 8 comma 2. Why it is 8 comma 2? Because these two lines intersects here. See here. These two lines intersects here. What is the corresponding point? This is the slope. Okay. The slope I get 8 comma 2. So what I am actually doing is, in this common area, what are all the border points I have? One is 0 comma 6. Another one is 10 comma 0. Another one is 8 comma 2. And substituting all the points in the given z equation, I am finding out for which points I am getting z as the maximum value. So when I am substituting that, I found that this 8 comma 2 gives me the maximum value because this is 128 is the maximum. So the x1 and x2 values are 8 and 2 respectively. So this is a simplex method using your graphical method. Thank you.